Production crashed after deployment with suspicious outbound connections. The root cause: a compromised Jenkins plugin pulled in a malicious log4j dependency, and without an SBOM, it went completely undetected. Let's break down Jenkins Supply Chain Security, how it works, and the exact mistake behind that failure. Supply chain security in Jenkins ensures every artifact has a software bill of materials listing dependencies, a cryptographic signature verifying origin, and a provenance attestation meeting SLSA levels. Think of it like ordering a custom PC. You want a list of components, SBOM, a tamper-proof seal Cosign, and a certificate of assembly standards, SLSA. The CycloneDX plugin integrates with Maven and Gradle to generate SBOMs. You install the plugin, then add a post-build action. For Maven, you can use the CycloneDX Maven plugin in POM, XML, or the Jenkins plugin's built-in integration. The SBOM lists all direct and transitive dependencies with versions and licenses. Cosign Keyless mode uses OIDC to authenticate the signer. Jenkins obtains an OIDC token from its identity provider, presents it to Fulcio, which issues a short-lived certificate. The signature and certificate are stored in an OCI registry. This eliminates the need to manage long-lived keys. SLSA defines 4 levels of build integrity. Level 1 requires a scripted build and provenance. Level 2 adds signed provenance from a build service like Jenkins. Level 3 requires non-forgeable provenance and a hardened platform. Level 4 adds 2-person review and hermetic builds. Start with Level 2. Use Cosign sign-blob to sign a file and output a signature and certificate. Then verify with Cosign verify blob. For Keyless, verification automatically checks the certificate chain against Fulcio and Rekor. Always verify artifacts in the deployment pipeline, not just in the build pipeline. For Maven, add the CycloneDX Maven plugin and run mvn-org, CycloneDX Maven plugin, make BOM. For Gradle, apply the org, CycloneDX, BOM plugin. Run this step after mvn clean install to ensure all dependencies are resolved. Store the SBOM in a central repository with a unique version tag. Cosign stores signatures in OCI registries as separate tags. Use Cosign attach signature to attach a signature to an existing image, or Cosign sign, which automatically pushes the signature. For production, use a dedicated registry for signatures to avoid clutter and allow different access controls. Keyless mode uses OIDC to authenticate. Jenkins obtains an OIDC token, presents it to Fulcio, which issues a short-lived certificate. The signature and certificate are uploaded to Rekor, providing an immutable record. Verification automatically checks Rekor for the signing certificate. In-Toto Attestations provide a sign statement about the build process, including source repository, build command, and builder identity. Use Cosign attest with a predicate file containing SLSA provenance. The attestation is stored as an OCI artifact and can be verified with Cosign verify attestation. Deployment pipelines must verify signatures and attestations before deploying. Use Cosign verify for container images or Cosign verify blob for files. If verification fails, the pipeline should fail. This prevents deployment of tampered or unsigned artifacts. To block unsigned artifacts, add a gate in the deployment pipeline that checks for a valid signature. Use Cosign verify, and if it fails, the pipeline fails. Additionally, use the Supply Chain Levels plugin to enforce a minimum SLSA score. Implement a break glass mechanism for emergencies, but log all overrides. Docker Content Trust uses Notary to sign and verify images. Enable it by setting Docker Content Trust equals 1. This forces Docker push and Docker pull to sign and verify images. However, Cosign is more flexible and supports keyless mode and attestations. Use both for defense in depth. GitHub and GitLab can act as OIDC providers for Cosign keyless signing. Use the OIDC token from the provider and pass it to Cosign. The attestation ties the artifact to the source repository and pipeline run. This integration is key to achieving SLSA Level 3+. This is the same issue we highlighted at the start. Here's exactly why that happened. a compromised Jenkins plugin downloaded a malicious version of log4j from a mirror. The build did not generate an SBOM, so the malicious dependency was undetected. The artifact was deployed to production, leading to a security breach. The pipeline lacked SBOM generation, so malicious dependencies like log4j went undetected. Adding CycloneDX plugin generates an SBOM that can be scanned for vulnerabilities. The fix was to enable the CycloneDX plugin to generate an SBOM for every build and store it alongside the artifact. We implemented Cosign signing and verification to ensure artifact integrity. Additionally, we added dependency scanning against the SBOM to detect malicious dependencies before deployment. A common mistake is generating the SBOM before dependencies are resolved. The SBOM will only show project dependencies, missing transitive dependencies. Always run mvn dependency, resolve, or mvn install before SBOM generation. Using long-lived keys and storing them in Jenkins credentials without rotation is risky. If the key is compromised, an attacker can sign malicious artifacts. Use keyless mode or rotate keys regularly with automated scripts. Skipping verification in the deployment pipeline allows unsigned or tampered artifacts to be deployed. Always add a Cosign verify step before deployment to ensure artifact integrity. Cosign Keyless mode requires Cosign experimental equals 1 for versions before 2.0.0. For Cosign 2+, this flag is no longer needed. Keyless is the default. Ensure your Jenkins environment uses Cosign 2+ to avoid confusion with the experimental flag. The article mentions the CycloneDX plugin, but does not show a complete pipeline stage. Here is a concrete example that runs Maven dependency resolution before SBOM generation, attaches the SBOM as a build artifact, and archives it. Rekor transparency log can experience latency or downtime. In production, consider running a private Rekor instance or using tlog upload equals false for non-critical artifacts. However, note that verification may fail if Rekor is required. Plan for fallback verification methods. To debug, first check that SBOM generation runs after dependency resolution. Verify that the OIDC token is valid and not expired. Monitor Rekor transparency log for unexpected entries. Use the supply chain levels plugin to score your pipeline and identify gaps. Let's run through some common interview questions. How to achieve SLSA level 2 in Jenkins? Generate signed provenance attestations using Cosign and In-Toto, and verify in deployment. Difference between Cosign Keyless and keypair. Keyless uses OIDC for ephemeral certs. Keypair uses long-lived keys. Keyless eliminates key management. How does Rekor help? Provides immutable log of signing events for audit and non-repudiation. And a few frequently asked questions. What's the difference between CycloneDX and SBDX? CycloneDX focuses on security, SBDX on license compliance. Can Cosign sign non-container artifacts? Yes, Cosign sign-blob signs any file. Do I need public Rekor? No, you can run a private Rekor instance. Key takeaways: always generate an SBOM for every build. It's your dependency inventory. Use Cosign Keyless mode to sign artifacts. It eliminates key management. Store signatures in an OCI registry, separate from artifacts if possible. Verify signatures in deployment pipelines and block unsigned artifacts. Start with SLSA level 2 and iterate. Ready to go deeper? Up next, Jenkins backup and restore, then Jenkins Kubernetes integration, then Jenkins Groovy scripting for pipelines. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.